Alright guys, in this video we're gonna do one of probably the smallest e-foil I've ever did in my career. The board I'm using is a PUM 29 liters full carbon construction. The board itself weighs at 3 kilos and it's very light. We're gonna start by, of course, some lining. We have to make the battery in the middle, of course, and should be not that far off from the rail line. Here I'm marking some lines, some guidelines. That's the stencil I will be using for the battery. So the problem with a full carbon board construction is related to the signal. You have to make a cutout in the front, especially if you use a very small board as this one. Otherwise the signal won't go through and you will have some connection issues. So the whole process here is to find the center, mark out the stencil, and of course have the guidelines to be able to do the cut and everything. This board itself is made from a very good high-end carbon. It's very stiff, doesn't get bump up if you hit it. Such a very good board, and also the shape of it is it's very well done. Levitat's actually made probably the best boards on the market at the moment. Alright, so now I start by cutting the guide I did. And this one is actually a pretty tedious process. The board itself should be very not moving and slipping because like a small error here will cost a lot, and you have to do it right. Here I try to also vacuum out some of the dust, carbon dust. Of course I wear a mask, and you don't want to mess with those powders. They are very dangerous. So this one is actually the smallest board I ever did. If you see from some out-of-the-shelf product on the internet, the smallest one you can go is from Flightboard, and it's a 49 liters, the Ultra L, and it tops out at 18.6 kilograms, which is actually very light. I actually drove not the Ultra L2 but the Ultra L, and was a very smooth experience. Actually very difficult to stand on since of the low volume board, and especially because I use it in dull water, and the buoyancy is not high as you get from the sea. So here it's actually pretty risky because 29 liter is very much almost 20 liter less, and there are a lot of chances I won't be able to stand on top of it, especially because it's very short. It's a 4.2. So actually in the Mast building process I went with a regular e-foil configuration instead of trying to build something different, like incorporating the motor in the fuselage or something like that. This one is mainly because since the motor won't be down as much as on the monocoque configuration, you actually don't have that much foot pressure, and your chances are higher to be able to stand on top of it. So after the cut, I heat up the sheet, carbon sheet, and remove it. Was actually very well stick to the foam. I saw a video from Levitat's building this board, and they use these special foams which instead of the regular polystyrene, which actually absorb water after a long period, this one doesn't. The only problem related to this is the carbon fiber itself, and the lamination process has to be done under vacuum. Here you can see me making the hole for the receiving breakthrough. I 3D print in Multijet Fusion a cover to that, and I will glue it later with some windshield glue. Very struggling to make the hole, as you can see here, and also the drill itself has a tip, and I'm very scared to go through the whole board. It would be a very big mistake actually. Here you can see the cover, it will be up here, and the windshield glue actually is probably the most amazing glue I work with. Now I'm taping out the battery hole. So here I want to make a 1 centimeter bevel to have the glue to stick on. So I will keep the lid I removed earlier, of course laminating it a bit to make it stiffer, and I will remove the material from the inside here, making the hole and laminate everything again. So the whole process is to make waterproof compartment inside the board, which doesn't compromise the stiffness of the board, since it will be probably using for pumping as well, and make a connection in the rail area where I can actually just plug everything and have it directly connected to the ESC. Here you can see me cutting the outline perimeters, but the whole foam will be scraped off with a special tool. I used to use that tool just because I can leave 5 millimeters of a foam and don't have the signature protruding out from the other side. I'm very surprised about this foam because it's very tough actually. Like the whole foam itself could probably be able to hold my whole weight without the carbon's construction. So my main goal here will be probably make a very light board which I can actually use for jumps, so the main cool thing about the Ultra L is the weight and how small it is and how fast you can do turns and stuff, and that's actually a very good thing to have, especially if you're an experienced rider. This thing will be probably way more extreme than an Ultra L, and actually DIY itself, so I can tweak it as I like it in terms of battery construction and capacity and power levels and stuff. Let's just move on to the stripping. So here you can see the special tool. It's basically a spool maker. This one is a very long, tedious process, painful as well. It took me probably about 5 hours to do, and of course I could just simply rip it out from the side and stuff, but I won't be able to make like a 5 millimeter thickness foam, and rotoring out this foam, it's a painful process as well, so that's the only way to go. If you do rotoring out, you will probably have some vacuum problems. The filter will clogged up very fast, and is not the most practical thing ever. So just a small time lapse of me doing all of that, and of course everything was sanded down and level up, and then I went all the way to Milan for one of my friends, which actually has a carbon fiber industry, and he does some very good stuff. Here you can see me vacuuming the mold. I went carbon fiber all the way down except for one side, and one side was made from fiberglass. And the reason behind that is of course radio frequency transmission. Yeah, so here you can see me removing the valve and slowly removing the vacuum thing. So I went 3 layers of carbon on the bottom, of course something to remove the excess resin and releasing in between. The rest of the board making process is a bit of a secret, and I don't want to show the whole process here because it took me quite some time to actually came out with something personal, and I don't want to bring it out to everyone. Sorry about that. But here you can actually see the board laminated and done. You can see the cut hole for the power on button, charging port, and data port. So what about the mast? The mast is a Roberto Ricci design high modulus full carbon fiber construction quick release mast, priced at 1,500 euros. The mast itself have been CNC'd from one company nearby, and I'm making the rest by hand. So instead of going with some drills and try to remove the foam and risking to ruin a very, very expensive mast, I went in this direction because I have the knowledge and tool accessibility to put it back together as it should. And yeah, so here I basically remove the extra foam, try to make a curvature for the wire to be able to slide easily through. Of course, I have to drill a small hole in the aluminum shell itself, and this is where the wire will come from. The three-phase wire will be faced with a waterproof high current connector, and that thing will be plugged up directly into the rail of the board. The rail position hole is at the far back as the rail can actually offers you. This because probably it will be still a lot of point pressure, and that's the only way to go. So here you can see me cutting some carbon fiber. What basically I actually did was cutting the hole, putting a bit of polystyrene in the hole, and now I'm going to laminate on top of it. The goal here is to make probably a 3 to 4 millimeter thickness on top of the polyurethane, and then after, when everything will be set off, basically going to melt off the polyurethane by using some gasoline. So here you can see the lamination process. I'm using a very, very tough carbon fiber cloth, and resin itself is very, very important. Here I'm using some aerospace grade resin. Resin itself is important as much as the carbon fiber. For carbon fiber technology, we are very much very in top of the lead, because we are already getting some high modulus fibers, and the technology have been raising quite a lot. But in terms of resin, that's actually very, very important too, and this one is probably the best one you can actually use. It's the same one used from high-end aerial application, and if you compare it to regular standard resin, it's probably 2 to 3 times stiffer, and it's such a very good product to work with. Curing time is around 3 hours, so you have plenty of time to laminate and do all of the things you have to do with it. Of course, here will be the same process. I mask out the edges with some tapes. That tape is the Kapton tape, and you can basically almost sand on top of it, and you won't be making that much damage. So I went with this tape so I can sand the whole thing and level it up later. Everything, of course, will be placed under a vacuum and remove the excess resin. Of course, here I'm applying a bit more of resin, so I know everything will be fully packed and very, very wet. So now I'm applying the release foil. This one is nothing more than a nylon sheet of foam, and yeah. What else? This one is a carbon cloth, but I'm using as a resin holder. It's almost dense as cotton and works very good. Was an excess, so I ended up using it. So now, what else? Putting everything under a vacuum. I'm using this vacuum bag. I ended up trying to use the regular vacuum machine. The only problem with that thing is doesn't get as much vacuum as you should use, so I ended up using a real vacuum machine, and that basically shifted everything out. You really need a full vacuum for those applications. This is very important if you want to acquire the full strength of the plastic. Here I'm sealing everything up and vacuuming it out, but later I ended up using the regular vacuum machine. This was more like a fun try to see if it actually works or not. After all of that, there are like a lot of sanding. Like, you guys can't believe how much sanding went into that mast. And this is mainly because you can't really use very aggressive devices, otherwise you will end up like removing too much, and yeah. So there's a lot of sanding. Here you can unfortunately see the whole process, because after all of that I went with another 2 layers of lamination on top of that, and that's to, of course, achieve the full strength of the mask and regain all of the stiffness I actually lose by cutting that hole. Here we can see actually how it came out. Now, of course, putting some gas inside the mask channel to melt down the polyurethane, and also I want to see if there is any leakage. I see one in the top and one in the middle, and those leakage actually ended up of course repairing that, so don't worry. Here's some photo of the quick lock, the motor mount with the lamination on top, and yeah, you can see the motor was mounted later. The battery itself, I don't have a video of me making it, but it's a 12S 4P made from Molicel P50Bs, which at the moment are the best cell you can actually get. The full capacity is 860 Wh. Here you can see me wrapping the board. I went with wrap because actually makes the board more waterproof and protecting it. Here you can see the waterproof compartment, the cutout from the foam, the board turning on, and everything works properly. The whole board was, the whole compartment was sealed up with some windshield glue, and that's actually very waterproof. And you can also see the cutout in the front for the seat mounts. Everything was greased up and ready to go for the first flight. So here we are at the beach. I took two wings with me, the first one being very big and the other one being very small. I also have 3 sets of propellers to test, 2 blades, and a folding one. So first impression was this board, it's so fucking hard to get on top of it. It's like something I never felt before. Like, you really struggle with the front pressure, even with shrimps. and you really have to get used to it. Yeah, like you really need to be an advanced rider to be able to stand on top of it. What else? What are the pros? The feeling and the smoothness and actually agility this board have is something unparalleled. Like, probably this one is the first board which I can actually use for full pumping. Like I can just let off the power and pump out very easily. Another thing is the maneuverability is very reactive. Of course, you really get what you use. Like as soon as you go low in volume, you really gain a lot of maneuverability. This one by far have been probably the best board I ever did, my 10th build probably, and I will be keeping this board for quite some time. Like, I don't think you can actually have something better than this for regular applications. Here you can see me riding it at Garda Lake. I will be trying it in salt water soon as well. In salt water, since you will have a bit more buoyancy, it will be easier to stand and go on top of it. And what about the range? So with my battery set up without pumping, I get about 18 kilometers of range. The average consumption is around 560 watts till 800 if I use the big wing. With the small one I get around 1000 watt continuous power in regular wind conditions. Talk about the cost of the board. So everything was basically top of the line in terms of quality, and almost the best product you can actually get right now from the market. The total cost was around 6,800 euros, and without including the bags. With those we will be around 7,000 euro. And of course this is with the best components you can actually get on the market right now. So my last step was do ceramic coating on the board and everything, so it doesn't get damaged with salt water. Here you can see the full mast with the waterproof connector, the motor mounted, the propeller and everything, the bag, the wings which are still drying, and this one is the complete board. Here there is the latch up for the quick release, so you just basically plug the waterproof thing, put the mast here, one screw, and you're good to go. Very fast and easy setup.